concerns. Let me go to the class website and see what. Again, test one will be available online. This Sunday is coming Sunday, okay? So actually, I think it's available at 12 a.m. So it will be available like Saturday night. Okay. So Saturday night, let's make it 70 minutes. You actually, yeah, it's 12 a.m., which means like Saturday night, and it requires the Lockdown browser. Again, make sure that you download the Lockdown browser before taking the test, okay? I have some students, like for another class, we have a quiz, and some students, they waited until the deadline, like the deadline usually 11:59. They wait until 11:30 and they start taking the test or the quiz, and uh, they couldn't install the Lockdown browser and they missed the quiz. The Lockdown browser works better on a laptop. If you cannot use like a phone to take a test with Lockdown browser. Also, most of the time it doesn't work, I think, with the iPad or Chromebook. Chromebook, maybe it works for Chromebook, but it's better if you use a laptop or desktop. If you don't have a laptop or desktop, you can go to one of our rooms, one of our computer labs, and it should work there. The library, I don't think the library computers allow you to download anything, but our computer labs, they are ready, and I think it is installed there. You just go and take it. And I gave you like several days to take the test. So you
Dr.
have,
Bawan, I have a question.
yeah.
There is a for that Lockdown browser in another course I have, there was a practice test that it was part of that practice. It's the practice test where you walk through the steps to test your Lockdown browser on your equipment. Is that a possibility here? So then people will be able to do it prior to
Yeah,
taking the
yeah, I
test.
have practice test here. If you go under week, where is, yeah, here, you see my screen?
Okay, yeah.
Yeah, if you
Okay, yeah,
click,
that's good. So everybody should try that
yeah,
so they'll know ahead of time.
yeah, try that. Let me see how many took. Nobody tried this practice test. It's good to practice here. I have two practice exams. They are same, but one of them using the Lockdown browser. Okay. And you have 3 days. If you have any problem, of course, usually you should not have any problems unless there is something, unless you use, I don't know, I've been doing this for like the last 4 years. Some students, they have problems, especially if they use Apple products. I think they just go to the OTIC and they solve the problem for them. But if you use like Windows laptop or something, you should not have any problems, you know. And also you have time. You can go to the lab and take it. Okay. Okay. Any questions? I posted all the recordings, so the lectures we had in the last few weeks. So you will find them here under each week. These are the recordings. The last Monday lecture here. So today we will continue chapter 4. So for chapter 4, actually the next test will be for chapter 4. So our next test, I think it covers only chapter 4. So forecasting. So we learned like 3 or 4 different methods of forecasting, which are the quantitative methods, moving average, exponential smoothing, and weighted moving average. So our goal is to get the most accurate forecast. It doesn't matter which technique. So to do that, we need to compare the 3 methods or 4 methods. We learn 2 more methods, and then we decide which one is better for us. So better means like less error, okay? So we generally do this by selecting the model that gives us the lowest forecast error. So we are interested in lowering the error, okay? So the one which gives us less error is the best for us. So now, let me see if somebody is waiting. To do that, we need to find the error. When we say error, error means like the difference between the forecast and the actual. Okay, let's say I did the forecast for last year. I used like the weighted average, and then what I do this year, okay, I have the actual because it's last year already, and I have the forecast. I compare them, and then I say, okay, if I use the weighted average, I graph all the methods, and then find the error which I have between the actual and the forecast. So different methods are used. The first one is called mean absolute deviation. Mean absolute deviation. So from the name, I always tell the student, you don't need to memorize like the equations. So deviation, I go to the deviation, means like difference, so error. So you have the actual minus the forecasts. We always use A for actual, F for forecast. And then absolute, I find the absolute, and then mean, and then I find the average for the data I have. And the other method, mean square error, MSE, the same. Error is the difference, A minus F. Square is squared, and then the mean. Mean absolute error, the same. I find the difference, divide by the absolute, the average, the actual, and then find the absolute and the average for that. Let's see how we can do that. As I said, this is the equation for the MAD or the mean absolute deviation. You need to find the difference. It stopped working my pen for some reason. Find the absolute and divide by how many. Let's see how we do that here. So let's say this example, we have during the past 8 quarters, the Port Baltimore, the Port Operations Manager wants to test the use of exponential smoothing to see how well the technique works in predicting the tons unloaded. He guesses that the forecast for grain unloaded, so quarter is 175, which is here. So this is 175 here. And then alpha, they are trying to use two different alphas. Don't be confused. So this is are like two different forecasts, one for alpha 0.1 and one for alpha 0.5. Okay, they want to see which one is better. Okay, let's see. So we said we are going to use the MAD, MAD, the mean absolute deviation. So let's start here with 168, which is quarter 2. The actual is given. Okay, so 175, which is, that's the forecast, right? 175 plus alpha times the difference between these two. So we get 175.5. We do the same thing here, here for all the periods. And here the difference is the 0.5. So instead of 0.1, we have 0.5. We do the forecast. Oh, we use this smoothing, which we already did last time. Okay. Now, let's see which method is better for us. So here, any questions here? We did that last time. We used this equation to forecast the orders or the demand for each period. We did that.
Okay, so how are we getting the first number? Like, okay, so for
Oh,
the
it's given. It's given. This one, the 175.
No, okay, so up under that, you see how the next one for 159 that's unloaded. How do we get
159,
how do we
which,
get 170?
how do we get the 174? This?
Yeah. Oh, that's the answer to the equation.
Yeah, that's the
35.
equation. You see, it says ft minus 1, which is 175.5, okay, a plus alpha, which is 0.1, times the difference between this and this, which is this. So we plug in all the numbers in the equations. That's what we did last time. And we get all these numbers. And we do the same thing. The difference between this and this is alpha. The difference between this column and this column is only alpha. So we are doing two different predictions or forecastings using different alpha. Why we do that? We want to see which one is better for us. Like, let's say you have a car dealership and you want to do a forecast. Forecast is important because let's say you have your dealership and you want to know how many cars to buy or to bring next month or next year. So do I buy like 1,000 car or 10,000 cars or 100 cars? It depends because this will cost you money. It depends on the forecast. What's forecast? I use previous years. Oh, how many cars we sold in September last year? Or even you use the naive. You say, oh, we sold like 20 cars. I just bring 20 cars. Or you do forecast. If you have all the data, use any of the methods and do the forecast. And the more data you have, the better results you get. Because every extra car you buy, it might cost you money and you need security and insurance and space. That's the idea. And the same thing for other stuff, you know, if you have like a retail store, or if you have a factory and you are making stuff, making products, they use like forecasting. And as we mentioned at the beginning of this chapter, even for new technology, you know, when they come up with something new, they use forecasting, but they use qualitative forecasting when they have new technology because they don't have data. So they use groups, somebody with experience, salesman or something, to do the forecast for them. Okay. Any other questions? Okay. So we did the forecast, and now we need to find the mean absolute deviation. It's easy. You put the actual, you put the forecast in the second column. You find the difference. 180 minus 175 is 5. 168 minus 175.5 is 7.5, and it is absolute. So absolute. So since it is negative 7.5, absolute is 7.5. Okay, that's why we need the absolute, because we are interested in the difference. When we say difference, it doesn't matter in this case if it is positive or negative. It is a short or extra, okay? So we find the absolute, okay? You see 5, 7.5, and we do the same thing for the 0.5 here. And then we add them up. Add them up, we end up with 82.45 divided by how many? 8, which is the average. This will give us 10.31. And we do the same thing for the 0.5, we will get 12.33. Based on this result, the alpha 0.1 is better because their error is 10.3 tons. Okay, but here we have more error. So this one method is better for us. Okay.
Wait, you said which one is better and why?
This one, the one with the lower error, because that means this method has less error. This is the error, the mean absolute error or deviation from the actual. So when you say, okay, let me make it like, so I used both methods, and I find that one of them is 10 cars from the actual, and the other one is 12 from the actual. So which one is better? The one close to the actual, which is this one, because this has less error or deviation from the actual. Okay? These numbers are the deviations from the actual. This is the actual. This is the forecast. You see, you have 5, 7, but here you have more. You have more here. More error. So we select the one with less error. That's why we selected the 10.31, which is 10% alpha. Maybe if you try another alpha, there is a software which does this for you. Okay. Other questions?
No, sir.
Okay.
No questions.
Okay, so now we move to the other method. This is MSE from the name mean square error. It's the same. The first one called MAD, mean deviation absolute error. So here, mean squared error, okay? So we find the error, the difference, we square it, and then we find the average of the sums of the squares. Let's see how we do that. The same thing. We have the actual. This is the actual. This is something happened before, okay? So they got the actual demand, okay? So like similar to the example I gave. Okay, you have a dealership, you sell cars every month. And if you collect the data for 8 months for last year, you say, oh, in January we sold 180. In February, you sold 168, then 159. This is your actual. This is the forecast, which used 0.1, for example. So then you find the difference between this and this. 180 minus 175 is 5, is squared. In the previous method, we find the absolute. Here we square the difference. Square this, 5, square this, and then add them up. We call this sum of square. Sum of square. Sum of square. So, which is this number, which is 1526.52. We divide it by 8. So we get 190. So this result, we use it to compare with another method, okay? So by itself, the 190 for one forecast, it doesn't mean anything. So to be able to use it, we need to do it for another method, like for alpha equal to 0.2 or 0.3, and then we do a comparison between the two methods, okay? Similar to what we did here. Here we said, we compared this with this, we found this 10 and this 12, so this is better, less error. The third method is the percentage. The percentage is similar. Look here, what we need to find the difference between the actual and the forecast and divide by the actual and then by 100, add them up, then find the average. It's similar. Look here, the difference the same is 5. 5 divided by 180. I divide it by the actual. You will get a percentage. Then you multiply it by 100, which what we did here. Multiply every percentage or rate by 100. You will get rates. Add the rates up and divide by 8. So this will give you 5.59% is the error in the forecast for this method. Okay. In the MAD method, we said, oh, it is 10 tons. Here it's percentage. That's the meaning. This is a table where which method is used where. So we said the mean absolute deviation MAD, meaning how much the forecast missed the target. That's the meaning of that. We said, oh, okay, for alpha 0.1, an example for the forecast for grain and load was off by an average of 10 tons, 10.3. The MSE, how much the forecast missed the target, the square of how much. Exemplify the square of the forecast 110. This number doesn't, as I said, unless you have two forecasts. Mean absolute error, the average percent error. For the 10, the forecast is off by 5.59% on average. Okay. So these are the methods we use to find the error. Okay. This is the same example I just saw. I put it in different slides. Solution. Same, we said this is 10, this is 12. And then you can find, this is the MSE for both. You see also 10 using the MSE, 10 is better. And this is the MAPA if you want PE, if you want to do a comparison. This is 5%, this is 6%, 5.59%, this is 6.75%. Okay. Another method for forecasting, if there is a trend, so in this case, we need to add this trend. That's why we have this method, which is called exponential smoothing with the trend adjustment. That means we find the trend, which is T, and add it to the forecast. That's all. Okay. So if we have this problem here, we find F1 is given, F2, we find F2, F3 using the exponential smoothing, and then we have to use these equations to find the new forecast with trend. Ft is alpha AT previous period actual plus 1 minus alpha the actual, the trend plus the previous forecast. How do we find the trend? So the goal is to find the trend for the current period. Beta, the difference forecast plus 1 minus beta times the previous, this is the previous trend, the previous period trend. When we see TT, that means the trend for the current period. TT minus 1, the trend for the previous period. This is the current period, this is the previous period. And the same thing for A. AT actual for current, FT forecast for current, AT minus 1 actual for the previous period, FT minus 1 the forecast for the previous period. Let's see the example here. Steps are easy, just calculate the FT, and then when you have the FT, you plug in the FT and beta in the equation, find the T, the trend, and then add the trend. This will be called the FIT, which is the exponential smoothing with the trend. You just need to find the trend and add it up. Let's see here. So a large Portland manufacturer wants to forecast demand for a piece of pollution control equipment. A review of past sales as shown below indicated that there was a trend. So 1, 2, 5, 6, 7, 10, look, there is a trend. And we are given alpha and beta. So we were asked to find the forecast using a trend. Let's see. Step 1. Okay, so what we are given here, the actual demand. We are given the FT for the first period. And we are given the trend. To find the FIT for the first period, since we have the trend and we have the FT, we just add them up. So 11 plus 12 is equal to 13. So this is for the first period. For the second period, we need to find this T. To be able to find T, we need to find this, the 12.8. How do we find the 12.8? We put the equation, which is, we said alpha A1, alpha times the actual for that period, a plus 1 minus alpha F1 Q1. The 1 means here the period 1. So F2 is equal to alpha. Alpha is given 0.2 times 12 plus 1 minus alpha is 0.8 times the forecast for period 1 plus the trend. So I get the 12.8. Okay, now I have this piece of information. I just need to find this T and then add them up. Okay, let's find the T. The T, based on the given equation, is equal to beta. Beta is given F2 minus F1, which is the difference between these two, plus 1 minus beta, which is 0.6, times T1, which is already known. So it is 1.92. I just add these up to get the FIT. If you add them up, you will have 14.72. Okay, this is how we use this method. And we do the same thing for all the periods. If we plot, this is the actual, okay, and this is forecast including trend. Look, the green is the forecast. This is the actual. Look, it's good. It's almost the same. That's what we need. Fitting a trend line. This is the other method, which is my favorite method. Using regression. As you remember in chapter 6, we covered the scatter plot and we said using the scatter plot, we can find the fitted line or the regression line. So that's what we are going to do now, the same thing. So in our book, so if you are asked to find the regression line, the easiest way is take the data to Excel, plot the Excel, okay, the scatter plot, and add the trend line or the equation of the line in Excel. I'm not gonna use these equations. If you want to use them, you can. To find, to get this line, you have what? You have the intercept and the slope. So the easiest way, I'm using Excel to do that. So let's say we have this data. Instead of going over all these calculations, I just copy this data. Use this method. It's faster and easier. I take this data. I copy this data to Excel, okay? This is the fastest way to do that. I go insert a scatter plot and then add the trend line. That's the line which I am looking for. And then display the equation. That's it. We're done. I take this equation and paste it here. You see, that's my equation. It's the same equation they found using the hand calculations. So now, if we are asked, this is the x. Let me make this x a little better. So after I get this equation, I say, okay, what is the forecast for period 8? What you need to do, I just plug in the 8 here. The 8 is here. So I have 10.5 times 8 plus 56,714. That will be my forecast. See, that's what we did actually. It's called the least square method. If you are asked to find the least square line, the fitted line, the regression line, okay, they are same. Any questions? With this, we covered all the
No, sir.
methods.
No questions.
We covered the methods and the error. So let me show you here. What do we have? I put this assignment, extra assignment for you to practice. So you understand how these methods work. For example, here we have a hospital, they want to purchase an ambulance. The decision will depend on the mileage or whatever. So using 2-year moving average, the forecast for year 6. So we have here year 5. So when I ask you a question, I ask you to use a specific method using 2-year moving average. The 2-year moving average means if I want to find for 6, what's before 6? The 2 years before 6 is 5 and 4. So the moving average is easy. I add 3,800 plus 3,700. Since it is 2 years, I divide by 2. Okay, and then this will be equal to 3,750. So here I say year 6 forecast is equal 3,750. Okay, for example here. Oh, here I have students, you know, especially those who do not attend the meetings and they do not study. So as I said, use scatter plot to solve a question like this. I just copy the data, okay? I just take it to Excel. It's very easy. No, I don't want text. I just, it didn't take. Sometimes it takes it, sometimes it doesn't take it. Even I put it as a table data in Excel called Canvas. Sometimes probably you need to type it. You see, let me type it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see, I have 37, then 33, then 41, another 41, 55, 60, and then 53, and 59, and 61. I missed one of them. Let's say we have 9. I'm not going to solve the exact question. So I just do what I did in the previous example. You see, to get the equation, I just Yeah, sometimes I need to do it again. Sometimes this doesn't show up for some reason. Display the equation. Oh, this is the equation I need, okay? That's the equation I need. So I got the equation and then use linear regression. So first I say, okay, using a linear regression or scatter plot, I found the equation is equal to this and this and this. I put the equation here. And then using linear, calculate the number of Dr. Folk will see in year 11. Then I plug 11 in here. So for year 11, I have equals 3.6, but I need to see this in text box. I see the equation times 11 plus 30, whatever. Okay, it's 69. So I type here using a scatter plot. The regression line is, I type what I have. I type the equation, let's say 30x plus whatever, 35, 6, whatever. And then for year 11, I plug in whatever I have in the equation. So, okay. So this is a short assignment I put just for practice. Again, the test will be available online on Sunday. Try to take the practice test. There is a practice test. Look down browser, practice exam. There is another exam. Oh, practice exam without look down browser. Let me bring these down so you can see them. Practice exam. Look down browser, practice exam. Download the practice exam. Here. Yeah, this one, it's a practice, just practice questions. But that doesn't mean that you just study the practice exam. No, this is just like, it gives you an idea how the questions will look like, the format or something. Okay. Any questions?
No, I don't have a question. The only question I got is are you gonna be in your office today?
Oh, no, today I am online. I have like 3 meetings in a row.
Okay, I would still love to come come whenever you're in person.
Tomorrow, you can come see me tomorrow.
What time is best? Because we have career fair from 1 to 6.
I am available 12, 12:15.
Okay.
I finish my first class at 12:05. So 12:10, I will be in my office.
Okay. I'll be there at 12:15. And what
212,
room?
right hall
212.
212. Yeah, second floor.
Okay. Thank you so
Yeah,
much.
thank you. Okay, no questions. If you need any help, let me know. And
I have a question, but I
yeah,
wanted to wait until you were
yeah,
done
yeah,
with class.
yeah. What's your question?
I had
She
sent you
said
an
she was gonna
email.
wait till class over.
Or yeah, I wanted to wait till like class is over. I don't want to hold anyone up.
Okay. So if you don't have questions, we are done for today.
Thank you. Have a good day.
Okay, have a good day.
Yeah,
Have a
you
good
have a
day.
great one.
Thank you.
Thank you.